Assalamualaikum. My name is Muhammad Ifan Zamli, and my group will present about suicide rate in South Korea. And this is all my group's members. First, for our introduction, background of the studies. For decades, suicide has been leading cause of death for individuals aged from 9 to 24 in the country, making it both major public health concern and a social crisis. Globally, around 700,000 people die by suicide every year, and many more attempt. This tragedy does just end life, they also leave behind the emotion wounds for family, community, and even nation. South Korea has been long struggle with one of the highest suicide rate in the world. In 2015, the rate was reported at 28.3 per 100,000 people, and it raised to 28.6 in 2018. The issue is especially alarming among adolescents, with suicide being the leading cause of death for this group. Nearly 8% of teenagers report has been suicidal thought. A major risk factor is mental illness, particularly depression. People with psychiatric condition are especially vulnerable. This connection is well documented not only in South Korea but across many high-income countries as well. Next, for the problem statement, to understand the trend of suicide rate over this 19th year, we need a mathematical model that can accurately describe the change in the data. For this purpose, we apply two different methods. The first one is Lagrange interpolation method and the linear least square method. Lagrange create a polynomial that passes exactly through every data, ensure a perfect fit. However, while at all points it can be sensitive and may overfit the data. On the other hand, the linear least square method find a polynomial that may not go through every point, but it minimizes the overall error, giving us a smoother, more general approximation. By comparing both models, this study aims to find out which method gives a more accurate and meaningful representation. Thus, it will help us identify the best fitting model. For our objectives, the first objective is to approximate a polynomial and find linear function given its value at a finite number of points using Lagrange interpolation of polynomial and linear least square method. The second objective is to evaluate and compare the accuracy and effectiveness for both methods using absolute error.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shahmi. I will explain about the methodology for our group research. So firstly is the data. The data we collect is from World Bank data. The suicide rate for South Korea from 2000 to 2018. We start the data with 2000 as set starting point, which is X for 0, and the years are spaced evenly every 2 years. Next is method. Since we use two different methods, which is Lagrange interpolation method and linear least square method, first I will explain about the Lagrange interpolation method. We use this method to approximate and evaluate suicide rate in South Korea. So, as you can see, this is the formula for Lagrange interpolating polynomials method, where for each k is 0, 1, 2, and 2n. After we find the approximation equation for the Lagrange interpolating method, so we find the error to approximate value to validate the accuracy of this method, which is we use absolute error, which is true value minus approximate value. Secondly, for the linear least square method, we also want to approximate and evaluate the suicide rate in South Korea. So there is 6 steps in the linear least square method, which is first we write the linear function to be fit, which is fx equal to n0 plus a1x. Second step is we find and we use the normal equation in the matrix form 2 by 2. After that, for step 3, we find all the values for all the elements of the matrix. Next, we substitute the total of x, y, x squared, and xy into the normal equation in the step 2. Next is we substitute a0 and a1 into the linear function formula in step 1. The last step is we find the estimate value of fx. We substitute the value into the least square function where we got in the formula in step 1. After that, we also want to approximate the accuracy. We also use the absolute error. We use two different methods to compare which one the method is more accurate than others.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shami bin Muhammad Nazim. And now I will be reviewing about the result and discussion for Lagrange interpolation with the approximation polynomial of degree 9. So as you can see, this is the formula that we'll be using, where the px with the degree of 9, where we have already substituted the value into the formula. And as you can see from the table 3.1, the polynomial approximates the steady rate with minimal error for every years, starting from 2000 to 2010. However, errors grows slightly for later years, which starting from 2016 until 2018, suggesting limitations in extrapolation. So as you can see on the right side, there is a picture about the graph. Okay, so for the next slide, as you can see, there is a table 3.2 below, display the approximated values of the unknown data of the suicide rate for 2001 until 2019. So the values are obtained by substituting the values into the approximated polynomial of degree 9. So as you can see, the x indicate the leap of year, and also y indicates the approximated value.
Hi, Assalamualaikum. My name is Muhammad Alif Azmi Murad. I will present the next slide, which is the result for linear least square method. In this slide, I will explain how our group had applied the least square methods to model suicide rate trends in South Korea by using the data we get from the World Bank. In the table 3.3, it shows the total sum for x equal to 90, total sum for y equal to 354.99, the total sum for x squared equal to 1140.1, and the total sum for x times y equals to 3538.78. This value were used into the system of linear equations, which is a 2 by 2 matrix, to find the best fit line. By solving the system of linear equation, we will get the value for the a null and a1. Then by solving the a null and a1, we will get to solve the equation and get the regression equation, which is y equals to 26.1210 plus 1.0420x. Here, 26.1210 is the intercept and 1.0420 is the slope, meaning that the suicide rate increased by about 1.0420 units for every 1 unit increase in x. Next slide shows the graph approximate least square. The graph shows how closely the model fits the real data. The blue line represents the actual suicide rates, and the dotted line is the predicted trend from our regression model, which is y equals to 1.0420x plus 26.1210. It follows the real data fairly well and clearly shows an upward trend. The slope of 1.0420 confirms a steady increase in suicide rates over time, and the intercepts of 26.1210 gives the starting points when x equal to 0. The purpose of the least square method is to minimize the total square difference between actual and predicted values. The next slide shows that the tables 3.4 compares the actual suicide rate with predicted values from our model. It is also shows the absolute error and squared error for each point. For example, at x equal to 0, the actual value is 19.9, which is the predicted value is 26.1210 by giving an error of 6.2210. while at x equal to 14, the predictor is almost perfect with only 0.003 error. Lastly, at point x equal to 16 and x equal to 18, the errors are larger, which is over 4.4 units. This shows that while the model captures the general trends well, it is not always accurate for individual points. It performs best in the mid-range of the data. Next, I will pass to the next presenter.
Okay, so last but not least is the conclusion. So as you can see, the table for error comparison between methods. As you can see, there are two methods that we use, which is Lagrange interpolation and also linear least square, and the absolute error that we obtain. So as you can see, this we tend to choose the Lagrange interpolation since the absolute error is the smallest if you want to compare with linear least square. So the table 4.1 error compares which method is the best based on the accuracy and effectiveness of method. The result of the study indicates that Lagrange interpolating polynomials method is better since the error from Lagrange method is close to zero, which means more accurate than linear least square method. So finally, Lagrange interpolating polynomials method is more efficient and suitable for the data of this study. So the second objective has achieved.